Okay, let's start. So, I'm going back to the first few slides that we have on chapter 2. So, you go back and look at this software modeling stuff. This is where we have to learn about the registers, everything. Remember that? So, what's this inside your CPU? They call it software modeling. Right? That comes out with the registers. So, the first one that you always been using so far is about this one, the data register is 32-bit. And then you have the next one is address register. Program counter I'm going to explain today. And today we are going to concentrate on this particular register, which is very important. They call it status register. So all this is actually the software modeling stuff. So when they call it software modeling, it's related to this one. Okay, so you have the registers, especially all about the registers name. You have to remember those things and the functions. The functions is over here. The name is over here. How many of them is all over here in this table. Okay, so this is about the software modeling. So today we are going to learn about one register particularly. It's about the status register. So what's the function of status register? The function contains information on the results in the last instructions. Means that after you execute any line, the status register will give the results. Status very simple. Like for example, you want to know somebody's status. Analogy like Facebook or whatever is, I don't know, Instagram. Facebook, you have the status over there. Whether you're single, complicated, I don't know what your status are. So people go and look at your status. So same with this one, status register. You have to go and look what is the result on the status register. So it contains the information after you execute any lines command. Okay? So they call it system byte and the conditions code register, which is CCR. So remember these all things, So now we go for the status register. I'll go back to the 4th chapter and go back to the middle of the slides. So you have to refer the slides, you have to do the programming, you have to do the simulator, then you understand. If you don't have the slides with you, it's going to be a tough one. Because you are not referring to what we are learning from the slides. Okay, look at the status register over here. The size is 16-bit. They have the red color, they put it red color over here and the blue color. So the one that I'm going to ask you to concentrate is only one color, which is the blue color. The red color, we don't really care because that is all admin stuff. The one that we need to care today is the blue color and only 5 bits only. 5 of them. We have to remember these 5. One is the X, then N, then Z, and then V, and the last one is C. So all of them got the functions of itself. So 5 of them. Let's go for the first one here, C. What does it mean? C. Set if a carry occurs during addition operation or shift operation. Set if borrow occurs during subtraction, clear otherwise. The terms for the electronic set means is equivalent to 1. So when I say it is set is equivalent to 1. Set adalah 1. Okay? Then what did it say? Clear otherwise. Clear means is equivalent to 0. Because this is a binary register, so it's going to have only two values, 1 or 0. So that's the term. If I say set, it's equivalent to 1. If I say clear, it's equivalent to 0. Okay, so far? So the function is very clear. Carry means if you do additional or subtraction, if there is a, what do you call it? They call it borrow, or you have to carry over, then your C will be 1. If there's no borrow or carry over, your C will be 0. Then next one. Overflow is one of the quite confusing status. This is related to the sign. So I'll go to the introduction first, then we have to do it online. Set is equivalent to 1 if an addition of two numbers with similar sign or subtraction, two numbers with different signs change the destination sign. I'll go there on later. After this, we have to go through the simulator. Let's put it first. The third one is very simple. 0, Z for 0. 0 set, Z will be set to 1 if the results of the subtraction is equivalent to 0. So it means that, for example, A minus B is equivalent to 0. Your status register Z will equivalent to 1. For example, very simple. This is not A, B lah. So it should be A minus A. B, if the same one is a value with the B. Okay? If the subtraction does not resulted in 0, your Z will be cleared. Okay, next one. Negative. Negative also quite simple. Negative means that set if the result of the operation is negative, which means that you have to look at the results of the output and look at the MSB value. Okay, that's one you have to do one way. The last one, extend, just copy the carry bit for arithmetic operation. That's all. Okay, 5 of them first, Still blur, I know. So let's try the coding. Turn on your PC. Okay, that's the code. Okay, quick one. So before this, you only concentrate on the executions of only the registers for data and address. So today you have to look at another registers from your compiler. Done? This one should be very fast. You are very familiar already with the code. So, before we look at the compiler, the command is very simple, sub.long d0 d1 or sub.bytes, much easier. Let's try sub.bytes on here, sub.byte. I just want to see two only, I don't want to have more. Okay, so D1 minus D0. D1 minus D0, look at this. So it's a 55 base 16 minus 44 base 16. This is equivalent as 1116, right? From your calculator. Right. So now look at the compiler where you should look at. Execute. So you have this data register. You have this address register. You have to look now at this status register. This one. And only 5 bits that you need to concentrate on, which is the X and Z, B, C. Okay, now you execute the line, look at the result. So I'm going to load here, load, and after subtract, what happened? Is there anything else happen? Nothing happened? So okay so far? If you get nothing happen, it should be okay. Because you have to go through the process first. So let's step right now, change the value now. Change your code from 55 to 44. And then do the same process again. Look at the CCR codes over there again. Is there any changes or not? Any changes? So, which bit is changing? Why? Because it's defined just now. If any operations, subtraction, that equals to 0, then your status register for the Z will be set. So just now, when you do the 55 minus 44, the result is not 0, right? So it remains clear. Agree? So it's clear cut. 0 is very clear cut. Any resultant is 0, then your Z will be 1. If the result is thus not 0, it remains clear. By default, all the status register is clear. By default. Nampak? Agree? Faham eh? Okay, let's try another one. Change 44 is 1 to 88 and then subtract, change to add. Now is 8, 8, 16 plus 4, 4, 16 is equivalent to BC, right? Is there any changes now again on the status register?
Negative.
How many change? Only one? 4? What flag? N. N. Right? So that N represents, it is not a negative number basically, that is a positive number, right? That is a positive number, correct? It represents the sign of the result. C is equivalent in binary is 1, 0, 1, 0, 1, 0, 1, 0. Right? This is still a positive number, but the rules for the CCR say if the results of the addition, if your MSB sign here is 1, it is a negative sign. Even though it's a positive value, this is just need to tell you that the results of the MSB now is equivalent to 1. So that your N flag will be 1. $100. This is 12 or 13? 13, so it's 50. This is 10 just now, right? Okay. Nevertheless, the MSB is 1. It's the sign of a negative. But it's not a negative number, it's only a sign. So that's why your N is equivalent to 1. Okay? Alright? So let's try another one. Add two numbers. This one is 8, 84. This one is F8. Change again the values. Look at the results again. So you are showing my case. So as you click the add line, and then you can see something happen. The result is out already. So how many bits have been changed? 3. Everybody got the same one? There are 3 bytes. There are 3 bits have been changed, have been set. One is carry, one is X, XN, and the other one is the B, is overflow. Alright, everybody got the same one, right? Let's go one by one.
84 base 16 plus F8 base 16.
Just use your calculator and then this one for me. I didn't know.
170.
Sorry?
170.
17C16, right? Okay, look at the first one. This first one that you need to look at the C, carry. So right now, look at this one. 84 plus F8. 8 in binary is equivalent to 1, 0, 0, 0. 4 is equivalent to 0, 1, 0, 0. Plus F8. F is equivalent to all 1 and 8 is equivalent to 1, 0, 0, 0. So you add up this number. 0 plus 0, 0, 0 plus 0, 1 plus 0, 1, 0 plus 1, 1, 1, 1, 1, 1 plus 1, 0,
Carry 1,
0, then carry 1. So that's why your carry set to 1. C, your C flag. Semua C flag nampak tak? C flag is equivalent to 1. Overflow V is equivalent to 0. Your V is equivalent to what? 1 also. 1 also. You have V1, you have C1, you have X1, right? X is very easy. X is copy over from carry bit. You look at the definition just now. X is equivalent to the C bit. So you will copy the C bit. If C is equivalent to 1, your X will copy and also equivalent to 1. That's the definition. Go for the definition first. Before I go for the overflow, let's do some subtraction again. Alright, now try to do subtraction. D0 minus D1. You compile it, look at the answer. Compile it, look at the answer. Is there changes on the second slightly? Subtract what? You have the same result as well, right? You have the same one. You have the X and C all are sets. That is, of course, that's the second complement. It's negative number. Okay, right now. Look at the subtraction over here. When you look at this number, it's a small number minus big number, correct? It's just like 2 minus 4. Betul tak? Besar ditolak, kecil tolak besar. Small minus big number. F8, 84 is
smaller than F8.
Now you are looking at the subtraction, a small number minus a big number. Correct?
So right now is 84 minus F8.
So in your head that you already know that the outcome will be a negative number. If you are using your calculator right now, it will give you all F, something like one, right? I tell you last time, if you want to have the negative number, you will convert to hex. That is representing in second complements for a negative number, which is correct. Correct? So right now, can you tell me the result for the second complement? F, what is the other one? F, 8C. 8C. So let's look at the results here. Now, you know that if you change this one to binary code again, 8 is equivalent to 1, 0, 0, 0, 4 is equivalent to 0, 1, 0, 0, minus F is equivalent all this, 8 is equivalent like this. This one I cannot just simply use my head, I do not know how to this one, because you have to borrow something. Okay, small number minus big number. Like for example, in decimal, 7 minus 10. Sorry. 1,272. Let's say minus 2,000. So this one 7 minus 2, 7, 2. This one you have to borrow, right? From outside here. You have to borrow here, right? Remember that? So this one is about borrowing something. When you borrow something out, your carry is still going to be set as 1. Just now carry additional outside, right? Keluar. But for the borrow, you have to put in something, a number. The carry still will be set to 1. Now your result is over here, 8C. Your result here is 8C over here. So 8C is equivalent to 1, 0, 0, 0. C is equivalent to 1, 1, 0, 0, right? So the carry and extend is the same just now. It's a copy. Now the overflow is also 1, right? Okay, right. So we look at over here. Look at the table in the slides. Okay, what else? You have overflow or negative? Negative, negative because of this result. Is the sign for the MSB is equivalent to 1. So your negative will be equivalent to 1. V kosong kan? Your V is equivalent to 0 kan? Alright. Your V is still equivalent to 0. Kn is equivalent to 1 is because your MSB resultant, the MSB is 1. That's why the N will be set to 1. Okay? So this is the results over here. So why the overflow bit still remains 0? So look at the table on your slides. The slides is like this. The overflow is looking on the sign of the two operations and what is the results of the sign. This is the table. For example, say that so for this example, you have to look at here. This is 1, betul? This is 1 is considered a negative sign only. Negative sign.